Good day, everyone. Welcome to the live section of today's class. We're going to look at this year exam, paper 3, Mathematics, May, June 2023. So as you can see, May, June 2023, paper 3, variance 2. Now the first question is inequalities. Now the first question, we are asked to solve the inequality. You can see now there are some rules in equality I expect you guys to know. For example, if we have modulus of A equal to modulus of B, it's the same thing as A squared equal to what? B squared. I square both sides. And if we have modulus of X minus A equal to B X minus C, it's the same thing as X minus A squared equal to B squared. The logic is just squaring both sides. It makes the work easier in doing that approach. It makes the work easier. Now let's look at this question. Now we are asked to solve the inequality. Like I said, just square both sides. So squaring both sides of the question or equation given, we have 5x minus 3 all square. This is less than 2 square. Make sure you square every variable all square. Now from here, so 5x minus 3 all square, when you expand it, we're going to have 25x squared minus 30x plus 9 less than 2 square is 4. When you expand 3x minus 7 all square, we should have something like this. From a cow, that will be 9x squared minus 42x plus 49 with a bracket. Then bring this down, 25x squared, repeat it here, minus 30x plus 9 less than, open the bracket by 4. 4 times 9, that should be 36x squared. 4 times 42, 168x. 4 times 49, 196. Collect the likes 10. Likes 10 means this one comes here, this one too comes there, and plus 196 comes there. Remember, when they are moving or flipping to the other side, the respective sign also flips or changing. Plus 36x squared turned to minus 36x squared is minus 30x, plus minus 168 turned to plus 168, and this one turned to minus 196 less than 0. At the end of the day, when you simplify, we have minus 11x squared plus 138 minus 138x minus 187. Now less than 0. Now because of the minus beside minus 11, you multiply both sides by minus. You multiply through by minus, so we have 11x squared minus 138x plus 187. Of course, minus will affect the inequality sign, change to greater than 0. From here is now quadratic. We solve it quadratic form by looking for 2 factors, which is most likely minus 17x minus 121x plus 187 greater than 0. So when you factorize, what do you have? X into bracket 11x minus 17. Make sure what is inside this first bracket must be what is inside the other bracket. Minus 11x minus 17 greater than 0. Now I have a logic. There's a way I usually solve question like this. There's a way I solve question like this. What I usually do is now at the end of the day we have x minus 11, 11x minus 17 greater than 0. So from here, so what you do is this, without this sign, without greater than 0, in real sense, without the inequality sign, x will be 11 or x will be 17 over 11. You note that this 11 is large, 1711 is large, 1711 is this smaller value. Now, because this sign is greater than, because this inequality sign is greater than, so the larger value goes with greater than, and the smaller value goes with what? Less than. This is the answer, provided that the sign is greater than. If the sign is less than, that will be another tweak, which I will share in one of my topical videos. Now, number 2. Now, second question. Now, this question is based on the second topic also in the syllabus. That's logarithmic equation. And I expect you to be familiar with rules like this. Lane A minus lane B simply means lane A over B. This is one of the rules. Another one is power law. A lane B is the same thing as lane B raised to power A. Another law is this. When you have lane of two, when you have lane equal to each other like this, lane will cancel lane, so A is equal to what? B. So these are few of the laws available. Let's see how we can apply these laws to this question. Now, the first step, we have lane 2x squared minus 3. 2 lane x from one of the law, it means lane x squared minus lane 2. So from here we have lane 2x squared minus 3 equal to, this one is lane of subtraction from this law. It means lane x squared over 2. Now lanes are equal to each other, right? After simplification. So what left is 2x squared minus 3 equal x squared over 2. So here we cross multiply. So 2 multiply 2x squared minus 3. X squared comes out alone. At the end of the day, when you put the bracket, we have 4x squared minus 6 equal to x squared. We arrange. We have 3x squared equal to 6. So x squared equal to 6 over 3. X squared equal to 2. X equal plus or minus root 2. So that should be that. Okay. Now the next question. Is complex number. On an Argand diagram, sketch the locus of points representing complex number z satisfying this equation, complex number z. Remember, complex number z can be written as x plus iy. And this type of question, um, when you are asked to sketch locus is a circle. Locus is a circle. So which means that to sketch a circle, you need center and radius. Of course, I'm very sure you are familiar with equation of a circle in this form: x plus a all square, ab plus y minus b all square equal to r square. Equation of a circle in this form gives the center as, since it's x plus a, the center for x will be minus a, this is y minus b, to be b, while the radius will be r. This is a general form of equation of circle. I'm very sure you're familiar with that. So I'm going to express the given equation, this, as a general form for equation of a circle. But meanwhile, I need to clean this because of space. I expect you to have noted that form. So I'm going to express the given equation in the question as a general form for equation of a circle. So let me write the question. So we have this. We have this. Z, like I said, is x plus iy plus 3 minus 2i equal to 2. So let's rearrange it. It means x plus 3. I'm putting the real number together and the imaginary number. Just rearrange it to put them in one place, equal to 2. Of course, I expect you to note this, NB. If you have a complex number like this, a plus ib modulus equal to c, it simply means a squared plus b squared equal to c squared. I squared the real number plus the imaginary square without the I equal to c squared. So we're going to apply similar stuff to this. So this can be written like this. Can be written as x plus 3 squared plus y minus 2 squared equal to 2 squared. So now I've finally expressed it as equation of a circle. So which means I need to determine the center. In this form, the center for x is minus 3, y for y is 2. Then the radius is equal to 2. This is the first step in sketching a locus, the center and the radius. Then the next one is to sketch the. So now we have the center and the radius. So let's sketch the locus. Draw my line. I'm doing like this because my x value is negative, my y value is positive. That's why I'm drawing it in this side. Let me label it 0, minus 1, minus 2, minus 3, minus 4, and minus 5. So that's for x value, y value 1, 2, 3, 4. Remember, when x is minus 3, y is 2. This is it. Between minus 3 and 2. So minus 3. You know, it's a sketch. between, so let me put this, the -3, and put it. So what's our radius? Our radius is 2. Radius is, so I need to get the radius. I need to get the radius in the 4 part of the circle. From 3 to -1, that's the distance of 2, radius of 2. From this place, this center 2 vertically to 4, that's the radius of 2. Horizontally from -3 to -5 on the other side, that's radius of 2. Vertically from 2 downward to 0, that will be a radius of 2. So then we can now draw our circle. See it, at the end of the day, I've succeeded in doing my locus and reflecting the radius. So you can leave it like this, or take away this line, provided that you sketch it to reflect distance of 2 from the center to any edge, so your diagram is correct. Now the next question is find the least value. Find the least value of z for point on this locus. The same locus we drew earlier. We have to find the least value of z. So I need to draw the locus again. This is 0. Let me just draw it and put the value. And this side is 4. This is the center at 2. This is -1. This is -1. This -3. This -5. Now we are asked to find the least value of z. You can get the least value or minimum value by sketching a line from the origin. Sketch a line from the origin. A line from the origin to meet this circle, which is perpendicular to that line. You meet the circle. Now that's the least. So let me call this side T. Let me label it T. So the least value we are looking for is TO. How will I get TO? You know, I can still extend this line to the center and bring it down to form a triangle. So let me call this C. Let me call this point A. It forms a triangle, right? So look at the triangle. This is a triangle. This point is O. This side is C. This side is A. From the diagram, you know, AO, when you check the diagram, is 3. CA is 2, the radius. What's CO? Pythagoras theorem. CO square will give us 2 square plus 3 square. So CO will give us, I think, root 13. If CO is root 13, and I'm looking for TO. From that line of CO, you can see that CO is a combination of CT plus TO. So CO will be equal to what's CT? If you check it, CT is from center to edge of the circle, that's radius 2. What's TO? That's what we're looking for. CO, we calculated CO to be root 13 equal to 2 plus TO. Hence, TO, which is equal to the minimum value of Z, will give us root 13 minus 2. That's the answer. I believe it's clear. So let's move to the next question. The next question is a trigonometric question. Solve the equation. Now to solve this equation, so from what I'm seeing here, 2 cos x minus cos half x is an half angle and a whole angle. The half angle is half x, the whole angle is x. So it will be easier if I put coefficient or put the half angle as something. So put half x as, let's say, y. So x is now 2y. So now let's replace it back. So the real equation turned to 2 cos x. And what is x? 2y minus cos half x, and half x is y, equal to 1. Now, I'm very sure you've come across this equation, double angle formula, that cos 2a is 2 cos square a minus 1. So we're going to apply a similar thing to cos 2y. That will be 2 cos square y minus 1 minus cos y equal to 1. Open the bracket, we have 4 cos square y minus 2 minus cos y equal to 1. So when we arrange, so 4 cos square y minus cos y equal to minus 2, flip to the other side, turn to plus 2, and plus 2 plus 1, 3. So we have 4 cos square y minus cos y minus 3 equal to that's turned to a quadratic expression equation. So you have to think of 2 factors, or you can also use the quadratic equation formula. But 2 factors from this expression look as 3 cos y minus 4 cos y minus 3 equal to 0. So when you factorize, at the end of the day, when you factorize, it's going to lead us to cos y minus 1 and 4 cos y plus 3 equal to 0. So from here, cos y is 1, or 4, or cos y is minus 3 over 4. We call that y is half x. So y is half x, so cos half x equal to 1, or cos half x equal to negative 3 over 4. So from here, half x will be inverse cos of 1. So inverse cos of 1, inverse cos of 1, I think will give us 0, which means that inverse cos of 1 will give us 0, and also cos 360 will also give us 1. So from here, anyway, half x is equal to 0, so x is 0. Let's look at the other one here. Half x will be half cos of 3 over 4, so which gives half cos of 3 over 4 we give in radian. Our calculator must be in radian. Must be in radian. So arc inverse of 0.75, I think will give us 0.723, and you know it's negative. The 3/4 is negative. You now check the quadrant where cos is negative. Cos is negative in the second and third quadrant. Cos is negative in second and third quadrant. The second quadrant, the formula is 180 minus theta. That's pi minus the principal angle. That's pi minus 0.723. It's also negative in the third quadrant, and the formula is 180 plus theta, pi plus principal angle, 0.723. So half x will be 0.723. So pi minus 0.723, that gives 2.419. The other one, pi plus 0.723, that gives 3.865. So hence the value of x will be 0.723 times 2, 0.723 times 2, so 1.45 to 3 sigma figure, 2.419 times 2, that gives 4.84, 3 sigma figure, 3.865 times 2, that gives 7.73. And when you check the domain, the condition given is between, look at the condition on the first question, x must be in between x 0 and 2 pi, must be in between 0 and what, 2 pi. So hence the value of x is 0, 1.45, they are still between pi, 2 pi, let's say 2 pi is 6 point something, so 4.84 is also accepted, but 7.73 is not included, rejected. So the value of x, so most likely I choose x to be 0, between 0 and 1.45. Now the next one, complex number. The complex number question. A complex number 2 plus iy is denoted by a, where y is a real number and y is less than 0. It's given that y is less than 0, which means our value of y will be less than 0. In case they said we should simplify the expression function of a in terms of y, which means to find function of a in terms of y. And function of a comprises of a cubed minus a squared minus 2a. We need to find all this. Remember that our a originally from the question is 2 plus yi. So what is a square? A square is a times a, which is 2 plus iy times 2 plus iy, which gives, by the time you open the bracket, which give us 4 plus 4iy minus y squared. Let's look at a cube also. A cube is a square multiplied by a. So our a square is 4 plus 4iy minus y squared multiplied by a. A is 2 plus iy. So by the time you open the bracket, at the end of the day, your a cube will be okay, let me open the bracket. So normally 4 times 2 is what? 8. 4 times iy, I have 4iy. I'm done with that 4. Let's move to 4iy. 4iy times 2, 8iy. 4iy times iy, that's 4i square y square. I'm done with that. Minus y square times 2 minus 2y square minus y square times iy minus iy cube. Remember that I square is always minus 1. So a cube will be 8 4iy plus 8iy. That will give us 12iy plus I square is minus 1. So y square minus 2y square minus iy cube. At the end of the day, my a cube is going to give me something like this. Something like 8 plus 12iy. This minus 4 minus 2 minus 6. No. Minus 6y square minus iy cube. Now, so a cube is, okay, this a cube, so 8 plus 12iy minus 6y square minus iy cube. That's a cube. And let me substitute it to the function. So, and the function is, function of a, from the question, a cube minus a square minus 2a. A cube is 8 plus 12iy minus 6y square minus iy cube minus a square minus a square. So minus a square will be minus 4 minus 4iy plus y cube minus 2a. Minus 2a will be minus 4 minus 2iy. By the time you simplify, evaluate, at the end of the day, we have 6iy minus 5y square minus iy cube. So hence, your final answer must also be in form of complex number, which is I into bracket 6y minus y cube minus 5y square. That's it. Now the second question. So the second question, given that the real value of function of a, the section 5, the question is, now the question, the real value of function of a is minus 20. Find augment of a. Of course, augment generally, augment It's always like this. Arctan y-axis value over x-axis value as argument. And there are some rules you need to take note when you are doing argument. Let me quickly browse to those rules in one diagram. Base. Pay attention to this. Now, if your diagram falls on, this is my first quadrant. Let me call this is my first quadrant. If your diagram falls on the first quadrant like this, if it falls on the first quadrant in this form, this is your y, this is your what? X. Your argument here, your argument in this place will be arctan y over x directly. Your answer will be direct. But if it falls here, if it falls there, this is your y over x. If it falls in this quadrant, your argument will arctan y over x to get alpha, right? After getting alpha, so your final answer will be pi minus alpha. Are you with me? This is first quadrant. This is what? Second quadrant. Third quadrant, if it falls here, if it falls in this quadrant, that's third quadrant. That's the third quadrant. Your argument in this situation will be, this will always be your alpha. This is y, this is x. After getting alpha, your final answer will be, theta will be minus pi plus alpha. I believe you take note of that. I'm going to clean the screen, so I expect you to take note of it. But I've not discussed about fourth quadrant. So if your diagram falls on the fourth quadrant, it's quite easy. If it falls on the fourth quadrant, your argument will be like this. If it falls on the fourth quadrant, this is what I mean by the fourth quadrant. This is our alpha, this is our y, this is our x. So your argument will just be minus alpha. That's it. So let's quickly solve the question. Now, the real value of function of a is minus 20. And what's the real value of the function of a? The real value is the one without I. That's minus 5y squared is the real value of function of a, equal to minus 20. Minus cancel minus. Y squared is 20 over 5, 4. So y is plus or minus 2. Remember, from the initial condition, y is less than 0. So hence, the value of y accepted is minus 2. Since y equal to minus 2 is accepted, so the complex number a, which is 2 plus yi, will now be written as, so minus 2 will take the position of y, that will now be 2 minus 2i. So we are supposed to look for the argument of this. Sketch the diagram. It's going to fall here. minus 2 and what? Plus 2. It's going to fall there. Our y is minus 2, x is plus 2, it's going to fall here. So let's find our alpha. So here, from here, alpha will be what? Arctan of 2 over 2, which is arctan of 1 in radian, it give you pi over 4. So therefore, your final answer will be minus pi over 4 because it falls on the fourth quadrant. That will be the answer. The next question is number 6. The next question is number 6, numerical solution. That's numerical solution. Numerical solution number 6. The equation cot half x equal 3x has one root in the interval between 0 and pi, denoted by alpha. Show by calculation that alpha lies between 0.5 and 1. It's quite simple. This question, to show it, you must prove that there is change in sign from plus to minus or from minus to plus when you substitute. This is what you're going to do. Now this is it. We have cot half x equal to 3, which is the same thing as 1 over tan half x equal to 3. So, we have to show that alpha lies between 0.5 and 1 at the end of the day. So we have 1 over tan half x. The 3 comes there, become minus 3, right? Equal to 0. Of course, it's not possible to be 0. So let's just put it as function of x. 1 over tan half x minus 3 as function of x, because by the time you substitute 0.5 and 1, it cannot be 0. So let's do that. First, let's do when x is 0.5, that's 1 over tan half times 0.5 minus 3. So what is function of 0.5? So make sure your calculator is in radian. At the end of the day, I think it gives us plus. Let's check it. Make sure your calculator is in radian. Plus 2.416 plus 2.416. Now when x is 0.5. So the next one, put when x is 1, function of 1. That's 1 over tan half times 1 minus 3. I think that one gave us minus 1.1695. So since there is a change, there is a change of sign, from x 0.5 to x equal to 1. There's a change of sign from x is equal to 0.5 to equal to 1. So it's been proved. Our next question. Next question is show that if the sequence of positive value if the sequence of positive values given by the iterative formula is this, show that this equation converge, then it converge to alpha. It's quite simple. This is the usual question from CIE. What you do is just take away the subscript. Is xn plus 1, turn it to x 1 over 3, xn, turn it to x, plus 4 arctan 1 over 3 xn, turn the xn to x. First step. Now the second step is we arrange the equation to become 3x equal to x. It's like cross multiplying arctan 1 over 3x. Collect the like term. This comes there. I have 2x equal to 4 arctan 1 over 3x. So from here, divide both sides by 4. So when you divide by 4, then I have 1 over 2x equal to arctan 1 over 3x. Take the arctan to the other side, it becomes tan of half x equal to 1 over what? I think it's 1 over 3x. 1 over 3x. So from here, multiply both sides by 3x. So 3x cancel what? 3x. Then the question now become 3x tan half x equal to what? 1. And equal to 1. So hence the equation can also be written as 3x equal to 1 over tan half x. What I'm trying to do is I'm trying to prove back to the original question. At the end of the day, 3x equal to 1 over tan half x will give us what? Cot half x. This is what we are asked to show, that it converges to alpha, that it converges to the original equation. That's the meaning. It converges to alpha, to the original equation. The next question, question C. We have to use the iterative formula to calculate alpha correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay. Now remember that from the previous question, we are not giving any initial value, but alpha lies between 0.5 and 1. Between 0.5 and 1. So we need to get an initial value of x. To find the initial value of x, find the average of between 0.5 and 1, which is 0.75. So the average will be our initial value. X1 is 0.75. So if x1 is 0.75, what's x2? Substitute it to the equation, the previous equation, 1 over 3x, and x is 0.5 plus, from the equation, 4 arctan 1 over 3 times 0.75. Again, 0.75, that's our x. Let me write it clearly so it will be clear. We are using the initial model given. So I have x1. I need to get x2. Remember that the model is xn plus 1 equal to 1 over 3 bracket xn plus 4 arctan 1 over 3xn as the model. So if x1 is 0.75, what's x2? So x2 is xn plus 1, 1 over 3. Here will be x1, and x1 is 0.75 plus 4 arctan 1 over 3 times 0.75. Don't forget your calculator must be in radian. So in your calculator, so you're going to have 0.8076. Make sure your answer are in 4 decimal places or 6 until you see some similar occurrence. Let's get x3. You continue doing it until the answers are looking similar in 2 decimal places. To get x3, here this part will turn to x2, and x2 is 0.8076 plus 4 arctan 1 over 3 times 0.8076. In your calc, which is supposed to be in radian, we have 0.7911. You can see the answer is still far apart. We are going to stop when we have similarity in the answer. x4 will equal to 1 over 3. x3 will place this place 0.7911 plus 4 arctan 1 over 3 times 0.7911. This one gives us 0.7954. Okay, in 2 decimal places are still far a bit apart. This is 79, this is 80. And you approximate. Let's do one more time again. 1 over 3. This one will give us 0.7954 plus 4 arctan 1 over 3 times 0.7954. My answer 0.7942. x6 is 1 over 3, 0.7942 plus 4 arctan 1 over 3 times 0.7942. That gives 0.7946. I think we have consistent value 0.79, 0.79. So hence alpha is 0.79. That's it. Which is obviously between 0.5 and 1. 0.5 and 1. Now, the next question, question 7. The equation of a curve is 3x squared plus 4xy plus 3y squared equal to 5. We have to show that the y dx is what you are seeing on the screen. It's an implicit differentiation. Implicit. So what you do, let's differentiate this in implicit. The equation of the curve is 3x squared. I didn't rewrite it. Let's just differentiate. When I differentiate 3x squared, what do you write? That'll be 6x plus 4 open a bracket. We have two variables. Let's use product tool to differentiate that. Put down the first function x, differentiate y. In implicit differentiate y, put the y dx. And here, when differentiate just y, we have 1. Because you are differentiating y, put the y dx. Plus, now put down y, differentiate x, that's 1. So close the bracket back, we are done with that. Plus 3y squared, when you differentiate 3y squared, that's what? 6y. Remember I said when you differentiate y, you put the y dx beside it. The implicit rule. Equals to 5. Constant, when you differentiate constant, we have 0. So from here, so we have 6x plus 4x, the y dx, I'm trying to open the bracket, plus 4y plus 6y, the y dx, equal to 0. So you arrange and make the y dx the substitute formula. So when you arrange, we have 6x plus 4y of the same variable. The other one, take it to the other side. So minus 4x minus 6y. What is common to them is y dx. Now make the y dx the subject of formulae. So we have 6x plus 4y. 6x plus 4y over minus 4x minus 6y. So we can still simplify. So what do you have? 2 is common, so we have 3x plus 2y. The down part, minus 2 is common. I guess so. We have 2x plus 3y. 2 cancel 2, so at the end of the day, the y dx is minus 3x plus 2y all over 2x plus 3y. I think that's what they asked us to put. The next question, let's move. Hence, find the exact coordinate of the 2 points on the curve at which the tangent is parallel to this. The tangent, what they mean by the tangent is the gradient, the y dx, which is this one. This gradient is parallel to this. You know, when gradients are parallel, it means they are the same. What's the gradient of this equation? Y plus 2x equals 0. So y is minus 2x. So the gradient of this second equation is minus 2. So that, which is also like the y dx. Since the gradient of this is minus 2, the first one is that. Since they are parallel, which means that minus 3x plus 2y, now the first y dx, 2x plus 3y will be equal to this because they said they are parallel. Minus cancel what? Minus. Cross multiply. Then you cross multiply, we're going to have 2 into bracket 2 into bracket 2x plus 3y equal 3x plus 2y. Open the bracket. I'm going to have 4x plus 6y, 3x plus 2y. Collect the like terms. That will be x equal to minus 4y. Since x it's minus 4y, right? Since x is minus 4y, okay, let's substitute x equal to minus 4y in this equation, in the first equation. And the equation is 3x squared. Substitute x equal to minus 4y in 3x squared plus 4xy plus 3y squared equal to 5. So I can get the value of y. So 3x is minus 4y squared plus 4x, x is minus 4y multiplied by y plus 3y squared equal to 5. So from here I have minus 4y squared is 16y squared multiplied by 3. That will give me 48y squared minus 16y squared plus 3y squared equal to 5. Subtract to your stuff. 48 minus 16 plus 3, that will give me 35y squared equal to 5. Y squared is 5 over 35, 1 over 7. So y is plus or minus so y is plus or minus 1 over root 7. So what the question asks us to find the exact coordinate. One y is plus 1 over root 7. The other y is minus 1 over root 7. Remember that x is minus 4y. From here, x is minus 4y. Remember that x is minus 4y. So when you put minus 1 over root 7 there, here will be 4 over root 7. When you put plus 1 over root 7 here, here will be minus 4 over root 7. So that's the coordinate the question asks us to do. And the next question is number 8. Next question is number 8. The question is the variable y and x. And the next question, the variables x and y satisfy the differential equation as shown. You can see it. It's given that y is 0 when x is 1. Solve the differential equation. Okay. You know what to do to solve this kind of differential equation. You need to separate the variables. Thank God we have enough space to express ourselves. Okay. First, what I advise you to do is cross multiply. So we have e raised to the power 2x plus 1 multiplied by the y, 4 plus 9y squared multiplied by dx. Okay, separation of variable, which means function of x must be with the x, function of y must be with the y. So since it's like this, if we have something like this of this function, it simply means that the y over 4 plus 9y squared equal to dx over e raised to the power 2x plus 1. If you cross multiply back, you see that it's the same thing. Let me call this equation 1. If you cross multiply equation 2, you see that equation 2 is the same thing as equation 1 when you cross multiply. So at the end of the day, we succeeded in separating the variable, the y with function of y, the x with function of what? X. After separating the variable, the next thing is to integrate both sides. So okay, the next thing is to integrate both sides. Now this can be written as 1 over 4 plus 9y squared dy equal to integral. Okay, what we're going to do, we're going to do it separately. We are going to integrate it. Let me show you how to integrate them separately. Now, this side is A, this side is A, this side is B. For A, you know, when you check your MF19, we have some function constant. There's a particular constant that go like this. 1 over it's also in your syllabus. At the back of the syllabus, 1 over integral of 1 over x squared plus a squared. The answer is 1 over a arctan of x over a. When you check this constant, the a has no coefficient, the x has no coefficient, they're alone. But my expression, the one I represented as a, I can write that expression as this: 4 plus 9y squared, the same thing as 9y squared plus 4. And 9y squared can be written as 3y all squared plus 4 2 squared. In this case, 3y is in the position of x as an alphabet. 2 is the position of a constant number. Now the only difference is that in this constant, there's no variable beside x. But in what we are integrating, there is a variable beside y that alter this constant. In that case, it's still going to follow this format, but we just amalgamate a bit. So the integral of 1 over 3y squared plus 2 squared will be, like I said, in this case, this is a and this is x. The only difference is that my x has a function, but in the model, the way they model it, x does not have a function. So what we do is this: we just say 1 over a. Our a here is 2. Arctan. Here our x is 3y. That was stand as position of x. Divided by a is 2. This is supposed to be the answer if y does not have a function. But since y is having something beside it, after writing the model it is supposed to be, now multiply by 1 over that function beside y, that's 3. So the integral of a is integral of 1 over 3y squared plus 2 squared dy. So the answer will be 1 over 6 arctan 3y over 2. That will be the answer. That's a is the integral on the left hand side. B is the integral on the left hand side. The integral on the left hand side, that's integral. No, B is the integral on the right hand side. A is the integral on the left hand side. The integral on the right hand side, which is B, 1 over e raised to the power 2x plus 1 dx. Now let's integrate that. Now to integrate this, this one you just put u to be 2x plus 1 as the power will be represented by an alphabet. So the u dx will be 2 and differentiate it. So the u is 2 dx. dx is du over 2. That's dx. So we substitute it back to the equation. So b will be integral of 1 over e raised to the power u multiplied by, what is dx? Our dx is 1 over 2 du, right? So which can be, bring the constant half outside, we are left with 1 over e raised to the power u, which is e raised by minus u du. So I'm very sure you're familiar with, we have little space. I'm very sure you're familiar with this integral of e raised to the power kx is e raised to the power kx over k plus c. So hence integral of, so our b, which is this integral, half integral e raised to the power minus u du will be half e raised to the power minus u over minus 1 according to the constant. Now have minus half 1 over e raised to the power u. So hence b, the integral of b, the answer will be minus half e raised to the power u, where u is 2x plus 1 plus arbitrary constant. That's b. So we've succeeded in, so we should solve the differential equation, checking the space. Okay, we have little space. Let's just quickly manage the space. So hence, so back to our equation 2. So back to equation 2. So from equation 2, we've integrated the left hand side to be what? That 1 over 6 arctan 3y over 2 equal to, the right hand side is minus 1 over 2 e raised to the power 2x plus 1 plus arbitrary constant. So let's substitute, let's get the value of c. To get the value of c, remember the condition, y is 0, x equal to 1. And so when y is 0, x is 1, at the end of the day, when you put it into this, equation 3, then c will be 1 over 2e raised to the power 3. That would be our c. Sorry. Okay, let me just put it so for clarity. You can still manage the space. Substitute this variable y equal to 0, x equal to 1 in equation 3. We're going to get c as minus 1 over 2e raised to the power 3. So put c back in equation 3, hence. So we have 1 over 6 arctan 3y over 2 equal to minus 1 over 2e raised to the power 2x plus 1 minus 1 over 2e raised to the power 3. But the question asks us to express y in terms of x. That's to make y the subject of formula. What I will do first is to multiply both sides by 2. Multiply both sides by 2. When I multiply both sides by 2, both sides or individual by 2. This by 2, this by 2, and this by 2. I'm going to have 1 over 3 arctan. Permit me, I'm trying to manage the space. Equal to my C is not negative, this is positive. So I'll have 1 over e raised to the power 2x plus 1 plus 1 over e raised to the power 3. So now, I want to make y the sub the formula. After this, so I can still multiply both sides by 3. When I multiply both sides by 3, I think I'm going to have multiply both sides by 3. Then I will have arctan 3y over 2 equal to minus 3 over e raised to the power 2x plus 1 plus 3 over e raised to the power 3. Then 3y over 2 will be tan of this 3 over e raised to the power 3 minus 3 over e raised to the power 2x plus 1. So make y the subject formula. So y finally will be 2 over 3 tan 2 over e raised to the power 3, 3 over e raised to the power 3 minus 3 over e raised to the power 2x plus 1. That'll be it. Thank you. Let's move to the next question. The next question say that state what happened to the value of y. State what happened to the value of y as x tends to infinity. What happens to the value of y as x tends to infinity? Y is this 2 over 3 tan 3 over e raised to the power 3 minus 3 over e raised to the power 2x plus 1. When x tends to infinity, this one will be out. So y equal to over 3 tan 3 over e raised to the power 3. Alright. Okay, thank you. Please subscribe to my YouTube channel. I'll drop the second video of this particular question from number 9 to 10. Just 2 more questions in the second video. See you soon.